All right, guys, what we're looking at here is a question from 2012 that deals with parametric equations. This one actually is one of the more straightforward questions that I've seen. There's not a lot of trickery as long as you understand the formulas that it's asking you to use. This one's really straightforward. So let's go ahead and jump on in and look at this one. Okay, it says a particle is moving along the curve so that at any time its position is x at t and y and t at time equals 2. The particle of the position is 1, 5. So it's like it gives us an initial position here. Then it gives us dx dt and dy dt. So we know our velocity vector, basically, and it's going to ask us some questions based on that. So the first one wants to know, is the horizontal movement of the particle to the left or to the right at time equals 2? Well, in order to do that, all you have to do is plug 2 into dx dt, because dx dt tells us if we're moving right or left. Dy dt is the one that moves up and down. So when you do that, you plug that in, and when that happens, you get a positive number. And it doesn't even matter what that number is, it's just that that number is positive. So that means that we are moving to the right. That was easy enough. So this explanation right here is good enough, that number is positive, so it's moving to the right. Then we want to find the slope. Now remember, the slope in a parametric equation is dy dt over dx dt. And then we're going to plug in 2. So you're basically going to say the sine squared of 2 divided by the square root of 2 plus 2 divided by e squared. Now if you plug that into your calculator, you get 3.055, and that is your answer for letter A, both of those two things. Letter B wants to know, what is the x coordinate? Now remember, the x coordinates and the y coordinates, even though they work together, they technically operate independently. So if I want the x coordinate at time equals 4, I just have to take my x value that I start at, plus the integral from when that happens to when I want that of dx dt. So the square root of t plus 2 over e to the t. And when you put that into your calculator, what you get is 1.253. Again, understanding that x and t operate independently, and dx dt is like the velocity, if you will, in the x direction. Dy dt is the same thing in the y direction, makes these problems a lot easier to understand. The next one wants to know, what is the speed of the particle at time equals 4? Well, the formula for speed, it's the square root of dx dt plus dy dt. So I just plug 4 in for dx dt. And it's both of those are squared, so I'm going to square that, plus dy dt squared, so I get sine squared of 4, and then that's all squared. When I put that into my calculator, I get 0.575 is my answer. So there's my speed right there. Then it wants the acceleration vector at time equals 4. Well, without a calculator, this would be a very difficult question, but with a calculator, I just have to press like Math 8, and let my calculator take the derivative and then plug in 4. When I do that, I get negative 0.041 for my second derivative acceleration part of the vector for the x component, and then I get 0.989 for the y component. So that right there is my acceleration vector, and I let my calculator do all the work. So that one again, I also pretty easy on that one. Letter D, I want the total distance traveled from time equals 2 to time equals 4. When we do that, it's just the integral of our speed equation. So I'm just going to have dx dt squared, and I can type that in, plus dy dt squared. That is our speed formula. When we do the integral of that, then that gives us the total distance traveled from time equals 2 to time equals 4. You put that in, you get 0.0651. Again, I thought everything in this problem was very straightforward. It's very easy to understand what it's asking you to do. It just boiled down to whether or not you could remember the formulas to answer each of these questions. So hopefully that made sense. If you have any questions, please let me know.